to Introduction to Computers. Welcome to Introduction to Computers. Chapter 1. What are computers? Computers are electronic devices that follow instructions to accept input, process input, and then produce information. Let's look inside the computer. We have software and we have hardware. Computers are made of hardware. These are tangible parts of the computer or parts of the computers that not only can you see but touch as well. Software is a set of instructions that tell the computer what to do. So let's see what comes next as we see these in detail, starting with hardware. So these are examples of what hardware parts are, starting with the monitor. The monitor usually is described in inches, and using a monitor you can see whatever you're doing on a computer. Other examples of the central processing unit, random access memory, we have the processor. The processor is what determines whether your computer is going to act fast or act slow. So we have also the joystick, we have the speaker, we have the mouse, floppy drive, CD-ROM, hard drive, keyboard. We'll look at these in detail as we go on with this lesson. Hardware. The parts of the computer itself or tangible objects includes CPU or processor, and primary memory or main memory, input devices, output devices, and storage devices. So we have this case here which some people confuse as a CPU. So a case or system unit or cabinet, it is what holds the hard drives. Even the same central processing unit, you find it inside this case with other components such as RAM, which is random access memory, and we'll look at most of these parts in detail. Central processing unit, other hardware parts which are very important to the processing of the computer. We have the central processing unit, input units, output units, and memory. These make up what is called the information processing cycle. And let's look at it in detail. So inside the processing unit we have the control unit, and also have the arithmetic logic unit and the memory, which consists of RAM and ROM. So a CPU has three major components inside it. We have the CU, control unit, arithmetic and logic unit, we have memory. Inside memory we have RAM and ROM. So inside this central processing unit is where everything major is done. That's why you find it's called the brain of the computer. Inside, let's quickly look through. Inside the control unit, it's where all instructions on how to respond or not to respond are done. Arithmetic and logic unit is all mathematical and the logic operands are done, or rather are processed. And memory, as in remembering, you find that in RAM it is temporal, ROM it is permanent. RAM meaning whatever you are editing, it is temporarily stored in RAM. If you decide to save it, it goes into ROM, and we'll look at this in detail later. Let's look at these other components which are found in the information processing cycle. Alright, so here you see that exactly how data moves around. So when you type A, that is your data, using an input device, that is your input, it goes inside the central processing unit. And once the processor has made sense of what you're doing, you see it as output, using output units such as the monitor, and becomes information or knowledge. So depending on what you're working on, you can save it as auxiliary memory or external. Okay, we'll look at most of these in detail later. Let's move on. So, input devices. An example of an input device is the keyboard, and that's what we'll look at. A keyboard is an input device, and it translates data from that humans understand to one that the computer can work with. Most common are keyboard and mouse. Let's note that a computer is a machine. Therefore, it has a language that it understands, and that is machine language. And as a human, I understand human language. So for me and the computer to communicate, there should be a translation. So when I enter A, that A is translated into binary in which the computer can understand, because machine language is in forms of ones and zeros, which majority of us humans cannot understand. And before we can see it on output units or output devices, it is translated back into human language, and that way we are communicating with the computer. Other input devices are keyboard, mouse, scanner, pre-storage devices, optical microcognition, microphone, joystick. Other examples are point and draw devices, trackball, touchpad, touchscreen, magnetic stripes, smart card, and digital cameras. So you will note that touchscreen and digital cameras can be both input and output. Alright, hardware organization. So let's look at the CPU. The central processing unit is a specific chip, or the processor. As you see here, it's a small processor or central processing unit is found inside the system cabinet. A CPU's performance is determined by the rest of the computer's circuitry and chips. The central processing unit performs the actual processing of data. The speed of the CPU is measured in hertz. So just like the way they compute your brain, your human brain, you have everything that you think of how you respond to. It goes through your human brain. Even when you lift your hand, that instruction comes from your brain. Likewise, a computer also has a brain, that is the central processing unit, where everything that you can think of, whatever you decide to type, or when you switch on or off the computer, it goes through the central processing unit. As earlier we saw that a CPU consists of control unit, arithmetic and logic unit, and some registers. The control unit, it coordinates all activities of the computers, as I said, by determining which operations to perform and in what order to carry them out. It's like the boss of everything else. If it doesn't decide, the computer won't run properly. This control unit transmits coordinating control signals to other computer components. ALU consists of electronic circuitry to perform arithmetic operations such as addition, multiplication, and division. Alright, and logical operations such as AND, OR, NOT, and to make some comparisons such as less than, equal to. Primary memory is, when you think of your human brain, you use your memory to remember. So in primary memory, it enables the computer to store at least temporary data, programs, and intermediate results. And of two types of memory, RAM and ROM. RAM is the primary storage. It is temporal, or we can say it is volatile, meaning as you are typing, as you are editing, If you don't save, it will remain in RAM and it will be lost. We have ROM, which remembers for, you can say, let's say, forever. It keeps, and when your information is ROM, you cannot edit it, you cannot change it, you can only read from it. But if you decide to open and decide to add something to it, whatever you're adding, it is still in RAM. If you do not save it, it cannot be part of ROM. Now for secondary storage devices, which used to keep files and folders and everything, and the examples of these were for the hard drive and floppy disks. And of common secondary media, we have the diskettes, or additionally these days we have got what people call flash drives. Other common secondary media, we've got external hard drives, which you can add or remove to your computer. Yes, there's that hard drive which comes with your computer, but there are also those which you can buy. It is part of your computer. Other common secondary media of the optical laser discs, such as the CD-ROM and the DVDs. Output devices, pieces of equipment that translate, they process the information from CPU into that humans can understand. As I said earlier, when you enter A, that A will be changed into machine language using the combination of 8 bits or binary, and then later when you sit on the computer to be back into human language. Examples of output devices, we have monitors, printers, sound blasters, and those which control other devices. Let's look at software now. These are instructions that tell the computer what to do, and I've got two examples of software: application software and system software. The most important system software is the operating system, because it is a platform where everything else can run. Like a house has foundation. If there is no foundation, a house cannot stand. So it is a platform which allows other applications or other systems to run, so that you can easily interact with the computer. It makes it easy for us to interact with the computer, because machine language is not easy to understand. System software, the software that controls everything that happens in a computer. Let it be background software. It manages the computer's internal resources, such as the CPU, the RAM, input and output devices. Application software, these are tailor-made programs made for a specific purpose. Like if I want a program that can design graphics, I'll look for Photoshop. If I want a software that can simply be used to keep data, I'll look for Microsoft Access, for example. Earlier I said when a computer is being processed, there's that part where the equivalent of that human language is changed into bits. So if there's a combination of bits or more, that space or the measurement will increase. So the smallest unit we have, it's a bit, which is a 1 or a 0. And a combination of 8 bits, we call it a byte. A combination of 1024 bytes is a kilobyte. A combination of 1024 kilobytes is a megabyte. A combination of 1024 megabytes is a gigabyte. A combination of 1024 gigabytes is called a terabyte. So like that, as your file becomes bigger, the measurement also becomes bigger. There are 4 kinds of computers. We have the microcomputer, mini computer, mainframes, and supercomputers. A microcomputer, an example, is a personal computer. There are three types of microcomputers: of laptop, desktops, and workstations. Personal computer is a small or single user based on microprocessor. A workstation is a powerful single user computer. It's like a personal computer, but it has a more powerful microprocessor and in general a higher quality monitor. So we also have mini computers, mainframe and supercomputer. Mini computer is a multi-user computer capable of supporting up to hundreds of users. Unlike the microcomputer where it can only support one user at a time, a mini computer can support up to 100 people doing different things at that exact same time. Then I've got a mainframe, powerful, more powerful than a mini computer. It can support up to thousands of users at the same time. And of that, the supercomputer, bigger than the rest, can support up to 100,000 users doing different things at the same time on the computer. Mini computers are desk size, more processing speed and storage capacity than microcomputers. General data processing needs at small companies. Larger companies use them for specific purposes. We have mainframes. They are larger than mini computers and are faster in processing and can be stored in a building, can take up a bigger chunk of space compared to a mini computers. And we've got the biggest and the most powerful, that is the supercomputer. It can cover a whole building, mostly used for mathematics intensive calculations. And here we've got an example of how a supercomputer looks like. Characteristics of a computer: let it be big, small, large. They have all the same characteristics. 1. It can store data. 2. It makes data meaningful. 3. It is fast compared to how a human can do the exact same job. And 4. It can easily share information. So it can easily come up with more characteristics because a computer was made based on a human. So you can say a human can process information, but a machine can do it faster. A human can store data in its brain, but not only can a machine store, but can easily retrieve it. You see, because if you compare the machine to the way things used to be before it was made, it needs to come up with a lot more characteristics. Understanding the difference between data, information, and knowledge. Data, it is what you enter. I've entered A. Then, when it goes into processing, the computer will decide to make meaning out of it and to say, it's A. When that A is it is classified into a topic or unit, becomes knowledge. So as I said, data is the name given to basic facts such as names and numbers. Then information is data that has been converted into more useful and intelligible form. Knowledge arrangement of information and classification of information of the same type or same topic. For example, I decided to enter -2, 4, 0, -3, and 10. When I decide to sort them out, to make sense out of it, let's say from the small to the biggest, -3 to -10, it becomes information. If I classify this to a topic, it becomes knowledge. Becomes information. Processing data produces information, and processing information produces knowledge. Keep that in mind. Lastly, let's look at computer viruses. A computer virus is an application program that is designed and written to destroy other programs. It has the ability to attach itself to a program, then replicate. So a virus to first attach itself to an already existing program on your computer, Once you click to open that computer, it will continuously replicate itself. Examples of viruses which you can later look at in detail are monkeys, ABC, crabs, CIH. A virus program infects programs, documents, databases, and more. It is man-made. It can hide and reproduce. It can lay dormant inactive. So, is there something to be afraid of? No. Where there's a virus, there's an antivirus. So you should always note that any computer that you buy, it comes with an operating system which you looked at, and that same operating system comes with an antivirus. All you need to do is open that antivirus and update it. So for example, usually Windows operating system come with Windows Defender. Once you purchase the computer, locate Windows Defender, update it. You should always note that as long as you have a computer, there's a good chance a virus might find its way to your computer, so it's always best to stay protected. Antivirus programs can help. Sources of viruses. Of the internet, downloading and exchanges. Diskettes, exchanging information, let's say for example flash drives. Computer networks, if one computer is infected, it can easily find its way to the other computer on the network. How to know if you have a virus? You have lack of storage capacity. You'll find that you don't have much on your computer, but you check your hard drive, it says it's full. There's a good chance you're infected. Decrease in speed of executing programs. You find that at one point opening and closing programs wasn't a problem. The next, they're taking just too long to open. You can find it is infected. There's a good chance it is infected. Unexpected error messages, halting. Virus protection. The software package distributed with new pieces always includes antiviral program, as I said earlier. And the best way to cope with viruses is to recognize their existence and use an antiviral program. Alright. So this is a brief introduction to computers. So as a good student, listen to this video, and anything that you don't understand, research further. If you have any questions, leave questions in the comment box, and remember to subscribe. Thank you. We'll see